Hello friends, in previous video we have discussed about the isothermal process and work done during the isothermal process. In this video we are going to see isobaric process. Now what is the isobaric process? Isobaric process is the constant pressure process. Isobaric process is the constant pressure process. This is the PV diagram for isobaric process. In this diagram, this is the expansion at constant pressure. Pressure is constant P, initial volume is Vi and final volume is Vf, where A is the initial state and B is the final state. Suppose Ti is the initial temperature and Tf is the final temperature. Ti is the initial temperature and Tf is the final temperature. Next, equation of state for this process. The general equation of state is PV is equals to nRT. This is the general equation of state. For isobaric process, pressure is constant and volume is changes. Therefore, for initial state, equation of state becomes PI VI is equals to nRTI. But at initial state, pressure is P. Therefore, P VI nRTI. This is the equation of state for initial state, and P Vf nRTF. This is the equation of state for the final state, initial state and final state. Now next we have to find the work done during isobaric process. To find work done during isobaric process, consider the general equation of work done. काय general equation? W is equals to P dV. Work done is equals to P into change in volume. dV is the change in volume. In this case, pressure is constant. Therefore, W is equals to P. What is dV? Change in volume. Final volume minus initial volume. Therefore, Vf minus Vi. This is the work done. W is equals to P Vf minus Vi. Again, W is equals to P into Vf minus P into Vi. P into Vf minus P into Vi. The value of PVF is nRTF and value of PVI is nRTI. Therefore, W is equals to nRTF minus nRTI. Now nR is common. W is equals to nR in bracket TF minus Ti. This is the work done during isobaric process, and this is also work done during isobaric process in terms of volume, and this is in terms of temperature, where N is the number of moles, R is the gas constant, Tf is the final pressure and Ti is the initial pressure. This is nothing but delta T. Tf minus Ti is equals to delta T, change in temperature. Now next we have to find the heat supplied during the isobaric process. Heat supplied during isobaric process. For this, consider first law of thermodynamics. What is first law of thermodynamics? Delta U is equals to Q minus W. Delta U is equals to Q minus W. We have to find heat supplied. Therefore, Q is equals to delta U plus W. Delta U plus W. Value of W is nRTF minus Ti. Now we have to find the value of delta U. What is delta U? Change in internal energy. The change in internal energy is given by NCV delta T. This is the formula for change in internal energy. Here is the number of moles. What is CV? CV is the specific heat at constant volume. V stands for volume. And delta T is change in temperature. Therefore, delta U is equals to NCV. What is delta T? Final temperature minus initial temperature. TF minus Ti. Now we have to find Q. Put the value of delta U and W in this equation. Therefore, Q is equals to delta U plus W. Delta U N CV TF minus TI. TF minus TI. Plus, what is W? W is equals to NR TF minus TI. NR TF minus TI. N is common and TF minus TI is common. Therefore, Q is equals to N into TF minus TI. Common. What is remaining? CV. CV plus R. CV plus R. Now, again next relation. R is equals to Cp minus Cv. What is R? R is gas constant. Cp. What is Cp? Specific heat at constant volume. Minus Cv. Cv is specific heat at constant volume. Sorry, Cp is specific heat at constant pressure and Cv is specific heat at constant volume. Therefore, put the value of Cv plus R. Therefore, this minus Cv, R plus Cv is equals to Cp. Value of Cv plus R is Cp. Therefore, Q is equals to N TF minus TI into Cp. Value of Cv plus R. Therefore, Q is equals to N Cp TF minus Ti. This is the heat value for heat during the isobaric process. This is the work done during isobaric process in terms of temperature, work done during isobaric process in terms of volume, and heat supplied during the isobaric process. Now, for this isobaric process, remember this, delta P is always equals to 0. Because in isobaric process, pressure is constant. Therefore, change in pressure is equals to 0. Now, volume is changing. Therefore, temperature is not constant. Therefore, change in internal energy is not equal to 0. Change in internal energy is not equal to 0. Or also, change in temperature is not equal to 0. Remember this for the isobaric process. This is all about the isobaric process. Now, next process is isochoric process. Isochoric process is the constant volume process. Isochoric process is the constant volume process. The PVD diagram for the isochoric process. A is the initial state, V is the initial volume, Pi is the initial pressure, B is the final state. For final state, again volume is V and Pf is the final pressure. This is the constant volume process. Now, we have to find work done during this process, work done during the isochoric process. Now, general formula for work done is W is equals to P dV. W is equals to P into dV. dV is the change in volume. dV is the change in volume. In this case, initial volume and final volume is same. Therefore, change in volume is equals to 0. Change in volume is 0. Therefore, work done during isochoric process is 0. Work done during isochoric process is 0 because volume during this process is constant. Therefore, work done is 0. Now, we have to find heat supplied during the isochoric process. For this, consider first law of thermodynamics. First law of thermodynamics is delta U is equals to Q minus W. Delta U is equals to Q minus W. In this process, W is equals to 0. Therefore, delta U is equals to Q. Delta U is equals to Q. Meaning of this equation is heat supplied is totally converted into the internal energy. Heat supplied is totally converted into the internal energy. Now, formula for internal energy is delta U is equals to N CV delta T. NCV delta T. Therefore, Q is equals to N CV delta T. NCV delta T. For this process, remember delta V or dV is always equals to 0 because this is constant volume process. Volume is constant, therefore change in volume is 0. Next, the total heat is converted into the internal energy. Heat is converted into the internal energy. This is the isochoric process or constant volume process. The next process is adiabatic process. Now, what is the adiabatic process? In this process, no heat is allowed to exchange between the system and surrounding. No heat is allowed to exchange between system and surrounding. याचा अर्थ काय? Example consider करा. The gas is enclosed in the cylinder fitting with the movable piston. Isothermal process मध्ये काय होतं की सपोज गॅस जर एक्सपांड झाला तर टेम्परेचर काय होईल? डिक्रीज होईल. आणि आपण एक्सटर्नल हीटचा सोर्स देऊन टेम्परेचर कॉन्स्टंट मेंटेन केलं होतं इन आयसोथर्मल प्रोसेस. तर या केसमध्ये गॅस एक्सपांड झाला तरी पण आपण काय हीट सप्लाय करणार नाहीत. म्हणजे काय? नो हीट इज अलाउड टू एक्सचेंज बिटवीन द सिस्टीम अँड सराउंडिंग. एक्सटर्नल हीट आपण या केसमध्ये सप्लाय करणार नाही. त्यामुळे काय होईल? टेम्परेचर इज नॉट कॉन्स्टंट ड्युरिंग दिस प्रोसेस. टेम्परेचर इज नॉट कॉन्स्टंट ड्युरिंग दिस प्रोसेस. हीट सप्लाय न केल्यामुळं टेम्परेचर इन्क्रीज पण होणार नाही किंवा डिक्रीज होणार नाही. आणि एक्सपांड झाल्यामुळं काय होईल? तर टेम्परेचर चेंज होईल. Therefore, temperature is not constant and heat supplied is equals to 0. That is Q is equals to 0 for the adiabatic process. This is the PV diagram for adiabatic process. Now, for the isothermal process. Isothermal process साठी temperature constant होतं. म्हणजे काय? PI VI is equals to RT and PF VF is equals to RT. This is initial state, final state. याच्यासाठी काय इक्वेशन आलं होतं? RHS सेम असल्यामुळं PI VI is equals to PF VF. हे इक्वेशन आलं होतं because temperature is constant. But in adiabatic process temperature is not constant. Therefore, there is a relation PV raised to gamma is equals to constant. PV raised to gamma is equals to constant, where gamma is the ratio of specific heat at constant pressure to the specific heat at constant volume. This is also called as adiabatic ratio. This is also called as adiabatic ratio. Next, then equation of state for the adiabatic process. For initial state, PI VI raised to gamma is equals to PF VF raised to gamma. PI VI is equals to PF VF is for the isothermal process because temperature is constant. And for adiabatic process, PI VI raised to gamma is equals to PF VF raised to gamma. हे इक्वेशन पाहण्यासाठी आयसोथर्मल प्रोसेसचा व्हिडिओ तुम्ही सर्च करा. त्यामध्ये पूर्ण दिलेलं आहे की वर्क डन ड्युरिंग द आयसोथर्मल प्रोसेस. Now, next we have to find work done during adiabatic process. Work done during adiabatic process. For this, consider the general equation of work done. W is equals to P into dV. P is pressure and dV is the volume. In this case, pressure is not constant, pressure is varying. Therefore, taking integration, W is equals to integration of P into dV. Integration is from VI to VF. VI to VF, initial volume to final volume. Next, value of P. What is the equation? PV raised to gamma is equals to constant, which is C. Therefore, P is equals to C upon V raised to gamma. P is equals to C upon V raised to gamma. Put this value in this equation. Therefore, W is equals to integration from Vi to Vf C upon V raised to gamma into dV. C is constant, therefore taking outside of the integration, W is equals to C integration from Vi to Vf 1 upon V raised to gamma into dV. Now V raised to gamma, W is equals to C integration Vi to Vf V raised to minus gamma into dV, minus gamma into dV. Then apply the formula of integration. Integration of x raised to n is equals to x raised to n plus 1 upon n plus 1. Here the value of n is minus gamma. Therefore, W is equals to C. Integration of V raised to gamma is V raised to minus gamma plus 1 n plus 1 upon minus gamma plus 1. Therefore, W is equals to C, here taking limit Vi to Vf, V raised to 1 minus gamma upon 1 minus gamma Vi to Vf, Vi to Vf. Next, W is equals to C upon 1 minus gamma in bracket V raised to 1 minus gamma, limit from Vi to Vf. Now put the value of upper limit and lower limit. W is equals to C upon 1 minus gamma in bracket upper limit is Vf, therefore Vf raised to 1 minus gamma minus Vi raised to 1 minus gamma. Again, W is equals to C upon 1 minus gamma, here 1 upon Vf raised to gamma minus 1. न्यूमरेटरचं डिनॉमिनेटरला शिफ्ट केल्यानंतर साइन्स चेंज होतात पॉवरचे, therefore gamma minus 1 minus 1 upon Vi raised to gamma minus 1. Now this C is constant, C is constant. Pi Vi raised to gamma is equals to Pf Vf raised to gamma is equals to C, which is constant. Therefore put the value of C in this equation. Now Pi Vi raised to gamma is equals to C, Pi Vi raised to gamma is equals to C, and Pf Vf raised to gamma is equals to C. Value of C is Pi Vi raised to gamma and Pf Vf raised to gamma. Therefore W is equals to 1 upon 1 minus gamma in bracket C upon Vf raised to gamma minus 1 minus C upon Vi raised to gamma minus 1. Here is Vf, therefore value of C is Pf Vf, and here is Vi, therefore value of C is Pi Vi. Therefore put the value of C 1 upon 1 minus gamma Pf Vf raised to gamma upon Vf raised to gamma minus 1 minus Pi Vi raised to gamma upon Vi raised to gamma minus 1. Now solving this equation, W is equals to 1 upon 1 minus gamma Pf Vf raised to gamma. Now डिनॉमिनेटरचं Vf वरती शिफ्ट करा into Vf raised to gamma minus 1 minus Pi Vi raised to minus gamma plus 1 minus gamma plus 1. Now base is same, therefore addition of powers, W is equals to 1 upon 1 minus gamma Pf Vf raised to gamma minus gamma plus 1 minus gamma plus gamma cancel, therefore Vf raised to 1. काय शिल्लक राहील? फक्त 1 शिल्लक राहील. मायनस Pi Vi minus gamma plus gamma cancel, Vi raised to 1. Vi raised to 1. Therefore final equation is W is equals to 1 upon 1 minus gamma in bracket Pf Vf minus Pi Vi. This is the work done during adiabatic process. This is the work done during adiabatic process. For adiabatic process, remember this, the Q is equals to 0. No heat is allowed to exchange between the adiabatic process. Again, PV raised to gamma is equals to constant and Pi Vi raised to gamma is equals to Pf Vf raised to gamma. This is all about the adiabatic process.